Now, factors affecting the rate of reaction. It is from chemical kinetics chapter. Rate of reaction means what? Rate of reaction is defined as the decrease in the concentration of reactants with time change or increase in the concentration of products with time change. See, for example, reactants are converted into products, you know well. During time change, concentration of reactants decreases and concentration of products increases with time change. That is known as rate of reaction. What factors affect the rate of reaction we will discuss in this class. See, there are 4 factors which are influencing the rate of reaction. Number 1, nature of reactants. 2, concentration of reactants. 3, temperature. 4, catalyst. Number 1, nature of reactants. There are 2 types of reactions are taking place. One are with ionic reactants, the other is with covalent reactants. Ionic reactions are relatively faster than covalent reactions. Why? Because in the reactants which are covalent in nature, bond breaking and bond making both will be happened for carrying out a reaction. It needs some energy. For the breaking of covalent bonds, it needs some energy. So, covalent reactions are relatively slower than that of ionic reactions. Next one, concentration of reactants. When concentration of reactants increases, rate of reaction is also increases. It is because of effective number of collisions increases when the reactants are in concentration, higher concentration. Rate of reaction is directly proportional to the concentration of reactants. So, we will see the relation afterwards. The third one is temperature. What is the effect of temperature on rate of reaction? Temperature is directly proportional to the rate of reaction. Rate of reaction is directly proportional to the temperature here. When temperature increases, rate of reaction is also increases due to effective number of collisions increases or kinetic energy of molecules increases. See, in a chemical reaction, one reaction is taking place at 25 degrees Celsius. The same reaction is taking place at 35 degrees Celsius. The difference in temperature here is 10 degrees Celsius. For every 10 degrees Celsius rise of temperature, the temperature coefficient mu value increases from 2 to 3 times. And the fourth one is catalyst. Effect of catalyst on rate of reaction. Catalyst alters the rate of reaction. What is catalyst? Catalyst is the substance which enhances the rate of reaction without undergoing any chemical change. Catalyst decreases the activation energy of reactants and speeds up the chemical reaction, and the reaction completes very fastly. In presence of catalysts, particularly positive catalysts, increases the rate of reaction. Catalyst alters the threshold energy, activation energy, rate of reaction and rate constant. Catalyst does not alters Gibbs energy change, change in entropy, change in enthalpy and equilibrium constant. These things are not altered by catalyst. So, we will discuss one by one in more particular. For example, nature of reactants. Already I told you, ionic reactions are very faster. See, sodium chloride when reacts with silver nitrate to form AgCl precipitate and NaNO3. Here these are ions. Oppositively charged ions comes closer and form the products. This reaction carrying out very fastly. But covalent reactions are relatively slower than ionic reactions. Say for example, hydrogen and chlorine combine together to form 2 moles of hydrochloric acid. In this reaction, this bond is broken. This bond is need to break. Cl2 bond also need to break. So breaking of 2 bonds breakage of 2 bonds needed. And here 2 moles of HCl is formed, means formation of 2 moles of covalent bond is there. So 2 bonds are need to break, 2 bonds are need to form. For this, time is taking and energy is involved in this particular reaction. So it is slower when compared to ionic reactions. In the same way, we will discuss some more reactions in this. And second one, concentration of reactants. Rate of reaction is directly proportional to the concentration of reactants. R is directly proportional to C per N. R is equals to K into C per N. From this we can write R1 by R2 equals to C1 by C2 whole per N. See, from here we can draw a graph. Y is equals to mx. It is like y is equals to mx form. On y axis rate of reaction we have taken. On x axis concentration. So slope is positive, that is slope value is how much? K here. It is the effect of concentration on rate of reaction. In this, concentration of reactants increases, effective number of collisions increases, so rate of reaction is also increases. And the next one is temperature. See, temperature increases, kinetic energy of molecules increases, effective number of collisions increases, so rate of reaction is also increases. Here one point is there. For every rise of 10 degrees Celsius temperature, the rate of reaction increases about 2 to 3 times. That can be calculated in terms of temperature coefficient, that is denoted by mu. The formula is kT plus 10 divided by kT. So temperature coefficient is the rate constants at particular temperature which are differ by 10 degrees Celsius, that is mu value. And Arrhenius is a scientist who derived an equation which explains about the relation between rate constant and temperature. Arrhenius equation explains about the relation between temperature and rate constant. We will derive that one later. Okay. And the next one is what? Catalyst. Generally, in presence of catalyst, rate of reactions are faster because catalyst decreases the activation energy. Now, catalyst alters means change the activation energy, threshold energy, rate of reaction and rate constant. Catalyst does not alter Gibbs free energy, change in entropy and equilibrium constant. Sometimes chemical reactions, the rate of chemical reaction depends on the concentration of catalyst also. In some reactions, rate of chemical reaction depends on the concentration of catalyst also. For example, hydrolysis of methyl acetate in presence of acidic medium. In that, the rate of reaction depends on the concentration of H plus added. That is also the main point here. So these are the factors which are influencing the rate of reaction. Okay. Now, Arrhenius equation. What is Arrhenius equation? Arrhenius equation deals or explains about the dependency of temperature on rate constant, or dependency of rate constant on temperature. So which gives the relation between rate constant and temperature. So Arrhenius proposed an equation, that is K is equals to A into e power minus Ea by RT. K rate constant, frequency factor, Ea is what? Activation energy, gas constant, and absolute temperature. See here, when we apply logarithm to this, ln K is equals to, or log of A to e power minus Ea by RT. So log AB form, log AB equals to log A plus log B. According to that, log K equals to log A. So ln E cancelled. So we have minus Ea by RT. For our convenience, for getting graph, I just rearrange these terms like this. Log K equals to minus Ea by R. Of course, they are constant for that reaction. T plus ln A. So it is seemed to be Y is equals to mx plus C. We try a graph. In this, on y-axis what is there? Ln K. X-axis 1 by T. Okay. Here slope is negative. How much slope is? Slope value is m. M is how much? Ea by minus Ea by R. So intercept value is how much here? Ln A. Okay, this is one form of graph from Arrhenius equation, and we will get another form of graph also. See here how it is. Right. So what we get? Ln K equals to ln A minus Ea by RT, right? From this, what is log? Here base is E, 2.303 log. I substitute there, 2.303 log. Log K is equals to log A minus Ea by RT. So when we divide the whole equation by 2.303, what we get here? Log K is equals to log A minus Ea by 2.303 R T. When we rearrange the terms for getting a graph, log K is equals to log A. Instead of log A, I write minus Ea by 2.303 R into 1 by T plus log A. Y is equals to mx plus C. Graph. It is y-axis. What is there on y-axis? log. Log K. Here x 1 by T. Negative slope we are getting. Slope value is how much? Minus Ea by 2.303 R. Here intercept is how much? Log A. Okay. So from this equation we can derive this one. Log K2 by K1 is equals to Ea by 2.303 1 by T1 minus 1 by T2. We can derive. So the derivation is not needed for us. So you have to remember this form. And if you write in LCM form also, in LCM form T1 T2 in the numerator, T2 minus T1 we have. So this is another form of Arrhenius equation. Sometimes the problems are coming from this formula, using this formula. So this is Arrhenius equation. Arrhenius equation explains about how rate constant varies with temperature change. Okay, this is in this class. Thank you.